All right, for today we'll be looking at overview of quantitative analysis. Overview of quantitative analysis. And what do we mean by quantitative analysis? I've said it several times that when you are dealing with quantitative, then it means you are dealing with numbers, not words. Because when you are dealing with words, that is when you are we're talking qualitative, dealing with qualitative analysis. So in most cases, majority of us oftentimes mix this up, and it is really not good when you lack this research paradigm, that is the research approaches that we have, which includes quantitative and qualitative, while some people also add mixed method to it. So, but for the sake of this class, I would like to reiterate it again, that quantitative has to do with numbers, because this time around you'll be talking about using statistical analysis. You'll be working strictly with statistics. So what you have in your material, which has to do with overview of it, we're only trying to look at or to explain to one another the meaning, the process, and the importance of quantitative methods of data analysis in research. And this focuses on how researchers use numbers, statistics, mathematical procedures to study phenomenon scientifically and objectively. And what do we mean by quantitative data analysis? It refers to the process of analyzing information that is presented in numerical form. Again, it is presented in numerical forms. And according to Felix Obikeze, he noted that quantitative analysis involves covering data into numbers and subjecting them to statistical and mathematical manipulation in order to identify patterns, identify relationships, trends within the data. And quantitative data analysis goes beyond the surface level of just doing table reading. Table reading is you having 10 male in class, 14 females in class. In total, you have 24 in terms of gender. And you have to do the frequency and percentage of these. That is 10 times 100, which is 1000, divided by 24. And you also do the same for 1400, which is for females, divided by 24. We do these two together in order for us to be able to find the percentage. And we do what we call table reading by just describing. But quantitative research analysis goes beyond that. It ensures that we move beyond just table reading and enshrine ourselves into what we call interpretation of the table, and also give implication of the findings that we have in that table. And here we talk about quantitative analysis is subjected to statistical and mathematical manipulation in order to identify patterns, which can be done descriptively. You can also use it to identify the relationships. And when you talk about using it to identify relationships, we'll be looking at it from the angle of you testing an hypothesis to see whether or not there is a relationship or a relationship exists between an independent variable and also the dependent variable. These are some of the things we look at. We also look at trends within the data. So in simple terms, quantitative data analysis or quantitative analysis helps researchers answer questions such as how many, how often, what relationships exist between variables. For example, a researcher studying the effect of AI news presentation on journalist job security may distribute questionnaires to respondents and assign numerical values to response or the responses gathered from an array or a plethora of respondents that he has. So the collected data are then analyzed statistically to determine patterns and also to determine the relationship, which was the example that I gave the other time about gender, male 10, female 14. So what are the key ideas here? The key ideas is that data must be numerical. When you say data must be numerical, we are still discussing quantitative analysis. Dealing with quantitative analysis tells you that the data by force must be numerical. It has no business with words, because here you are expected to assign values to those numbers. So quantitative analysis works with data presented in numbers. I'm reiterating this again. Works with data presented in numbers and responses collected from participants please note that when you're dealing with quantitative analysis, you are not dealing with participants, but rather you are dealing with respondents. When you're dealing with qualitative research, then you are dealing with participants. So responses collected from respondents are converted into measurable values. For instance, if I'm to administer a questionnaire to 24 students and I want to look at their gender is of two as far as Nigeria is concerned: male and female. That is our orientation when it comes to gender. Male and female. Here we talk about assigning numbers to words, which is male. The number I will assign to it is going to be 1. Female. The number I will assign to female is going to be 2. If we are looking at universities in Offa, the number I will assign to Summit University is 1. The number I will assign to Lens University is 2. The number I will assign to University of Offa will be 3, so that I can use those numbers to run my own numerical analysis. And these examples include frequencies. These examples of analysis include frequencies, percentages, average. We talk about ratings, scores, or even scales. And also we make use of level of measurement sometimes, which includes the strongly agreed, disagreed, strongly disagree. While some research orientation of this Likert scale believe there should be neutral, you should be able to have a respondent that either agrees not, nor neither agreed nor agreed. So when it comes to statistical manipulation, which is the second idea behind quantitative data analysis, statistical manipulation here talks about after collecting your data, the researcher uses statistical techniques to organize and analyze the information. And the aim is to reveal trends, is to reveal characteristics, to reveal relationships, to reveal differences and patterns with the data. So this process helps the researcher understand what the data mean scientifically. For example, whether AI influences media credibility, whether social media affects political participation, or whether there is a relationship between digital literacy and fake news detection. The third idea, or the third key idea in terms of explaining quantitative data analysis, has to do with scientific and systematic approach. Again, scientific and systematic approach. I have the scientific and systematic approach because this tells us that quantitative analysis is scientific, meaning it is systematic, meaning it is step by step. It has its own rules. It has its own procedures. Once you jump a particular step to move to the next, it is going to affect the credibility or the efficacy of the entire thesis itself. You also talk about the scientific and systematic approach. You talk about objectivity, how precise it is, and how replicable it is. Replicable or replicability talks about the consistency of the data. That is, if I'm coming back again to test this data, am I likely to get the same answer? And this is what this one looks at. Next, we'll talk about the role of hypothesis testing. The role of hypothesis testing in this. And what are the roles of hypothesis testing? Like I said in one of your classes, an hypothesis is just a guess. So quantitative analysis often begins with hypothesis. So a hypothesis is a testable statement predicting a relationship between variables. Example, AI news presentation has a significant effect on journalists' job security. That is an hypothesis. But for you to be able to now affirm or confirm whether or not this is true, you have to put all of the data gathered under AI news presentation, meaning you are expected to have items. Item 1, item 2, 3, 4, 5 in your questionnaire. And when you use SPSS, statistical package for social sciences, then you can be able to compute all of these into one variable and you can use it to test it against journalist opinion when it comes to job security. So the researcher here uses what we call statistical tools to test whether the hypothesis is true or false. And how do we test whether this hypothesis is true or false? We test it using our significance, and we also use to test the degree at which it has an effect or at which it doesn't have an effect. We test this degree using what we call analysis of variance. And while we use our p-value, if the p-value with this alternate hypothesis, which states that AI news presentation has a significant effect on journalist job security, this is an alternate hypothesis. It becomes a null hypothesis the moment we say AI news presentation has no significant effect. The word no there makes it a null hypothesis. But when we are testing an alternate hypothesis, another way to test whether or not it is true or false is to look at the p-value. If the p-value is above 0.005, then we say we fail to accept, meaning we have to reject the alternate hypothesis. But if it is less than 0.005, then we accept the alternate hypothesis. The next we'll look at is the two major stages of quantitative analysis. Number one, which has to do with the descriptive analysis. This stage only summarizes and presents the data, and it answers the question, what does the data look like? In terms of percentage, how many males do we have? What is the percentages? Or what are the percentages? Or what is the percentage of the male? What is the percentage of the female? So common descriptive statistics include the frequency, percentage, mean, median, mode, and standard deviation. Again, frequency, percentage, mean, median, mode, and standard deviation. Example, if 70% of journalists believe AI threatens job security, descriptive analysis presents this result clearly. Its main function is to describe the characteristics of the data. Just tell us the numbers. You are not to tell us the implication. You are not to tell us the underlying meaning that you have in it and what are the future implications. Just the regular table reading is what is expected of us. And this also helps the researcher to test type. And the next we'll be looking at, so before we go to the next, the main function of descriptive analysis is just to describe the characteristics of the data set. The next is the inferential analysis. And what do we mean by the inferential analysis? It goes beyond the descriptive, as your inferential analysis helps you as a researcher to test the hypothesis, to determine relationship, to even make a prediction whether with the ongoing effects or impacts or influence between a particular variable on another variable, this is likely to be the effect in the nearest future. We use it to test in terms of making prediction, and we also use hypotheses, inferential analysis rather, to generalize findings from a sample to a larger population. And what are the common inferential statistics that we have? They include correlation, we have regression analysis, we have t-test, we have what we call chi-square. We use our chi-square as well to test relationship, and we have analysis of variance, which tells us the degree at which a particular variable affects another variable. Example, a researcher may use regression analysis to determine whether AI newscasting significantly predicts journalists' perception of job security. So inferential analysis here therefore explains why and also how this relationship exists. And the next we'll look at is the importance of quantitative analysis. Here, we are trying to highlight that quantitative analysis helps researchers to identify relationship among variables. We've talked about this. Explain social phenomenon scientifically, make predictions and generalize findings to wider population. And it also enhances validity, reliability, accuracy, and objectivity in research. And what are these simple illustrations about this? Suppose a researcher wants to study. Let us give us a simple anecdote towards this. Suppose a researcher wants to study effect of TVC AI newscaster on job security among broadcast journalists in Lagos. Again, the topic, effect of TVC AI newscasters on job security among broadcast journalists in Lagos State. The researcher here may distribute questionnaires, they may collect numerical responses, calculate percentages and averages, use regression analysis and to determine whether AI newscasting significantly affects job security. So this entire process is quantitative analysis in nature. So we can say quantitative method of data analysis involves the scientific examination of numerical data using statistical and mathematical tools, and the method enables researchers to identify trends, test relationships, explain phenomena, and make predictions objectively without having any bias. Looking at our philosophical assumption of research, which has to do with what do we call it? Axiology, which has to do with being value-free. Through descriptive and inferential analysis, quantitative research provides reliable and generalizable findings that contribute to knowledge development and evidence-based decision-making.